Okay, so you guys, we are going on here with lecture. This is going to be part two. Part two is very short. Okay, it's going to be probably about 10 minutes max. So this will be up on YouTube hopefully today, if not for sure tomorrow during my prep. The other one, which is the bulk of this chapter, right? It was a long lecture. It ended up being about 30-something minutes. Is already up there. It's been up there all weekend, okay? So if you were absent or if you need to just review some stuff, it's all there, okay, on the YouTube channel. And I put the link to it on Edmodo, right? Okay, so we're on to the human digestion. So let's review a teeny bit and make sure we remember what we talked about with this digestion section, last section. Okay, that needs to go. So there are two types of digestion. Do you guys remember what those are?
Extracellular.
Okay, so really then, hold on, those two words are talking about where the digestion is taking place. Not necessarily a different, I could see how you could say it's a different type of digestion, but within digestion of any organism, there's two types. Yeah, do you guys remember that? There is physical digestion and chemical digestion. Sometimes physical is also known as mechanical digestion. And when we were eating the crackers last time, when we were chewing them up, right, moving our mouth around, moving our tongue around, breaking that down into a ball of mushy food, right, which one was that? That's your physical digestion or your mechanical digestion. Now, did we have some chemical digestion going on in our mouth also? We did, and we had evidence of that because of the change of the taste of the chemicals, right? Okay, so do you guys remember what happened? What's the large polysaccharide that's in the breads and pastas that was being chemically digested in our mouth? Well, that's what it broke down to, was the sugar, but you remember the polysaccharide, the bunch of glucoses bonded together, what's that called? What? There we go. What's in breads and pastas and potatoes? They are carbs, but starch. And so starch does not taste sweet, but the chemical reaction happened in your mouth, and then you were tasting a little bit of some sweetness, what we wanted. Do you guys remember that? You wanted to take another bite. It was all about that sugar that we want. And it makes sense that we desire and want sugar. Why would we want sugar? Well, but why do we want it? That's where we get our energy, yeah. Okay, so again, saliva, right? That's the liquid in your mouth. It's not simply water. So this is a nice overview. And even on Pedro here, we can see here they have, that's your salivary gland right there that makes your saliva, the enzymes. It's behind that jawbone. The jawbone's on that side, but they cut it off on this side so you could see it. So when we look at this overview of human digestion, I'm pretty sure your other paragraph essay on the test, not really a full essay, but your paragraph response, is going to be trace food through the digestive system. And so you just want to walk through this. You start with the mouth, right? Your teeth, your tongue. You could see the salivary glands there secreting enzymes and different chemicals that are needed. And then what's the long tube called?
Esophagus.
Yes, the esophagus. And this is a muscular tube. It contracts and squishes the food. National Geographic's website did a great job of showing you that. Okay. Now, you can't see it here, but the esophagus dumps into what? The stomach. And in the stomach here, we have the pancreas, you have the liver, you have the gallbladder, you have these other things releasing enzymes and other chemicals that are needed for breaking down and further breaking down the food in the stomach. Okay, there's some chemical digestion going on in there, but there's a lot of physical digestion going on in your stomach. Okay, after your stomach, where does all this food stuff go? Yes, this is very important that you realize it hits the small intestines first. This is the most important organ here, or it's where we actually get to absorb it. We have not been pulling out the nutrients. We've been preparing this soupy sludge of food so that your cells can absorb the nutrients from that. Okay? And that happens in which organs? The small intestines. Now, the large intestines do not absorb nutrients. They absorb something else. So after your small intestines, you hit your large intestines. What is being absorbed here? No, so the small intestines are going to pull out the nutrients. But this is a soupy bunch of stuff here. What does your body not want to lose when it excretes the stuff it doesn't need, when it gets rid of the stuff? The water. Hugely important. So your large intestines absorb the what? The water. We needed a lot of water to get the chemical reactions going in this soup, and then we needed it in a watery deal also so that the nutrients could diffuse and come out of it. You guys are distracting me completely. So focus, look at me, concentrate. Okay, so then we have the rectum and the anus. Even the colon was up there right before the rectum also. And now we're just going to get rid of it. Okay, remember, are we doing extracellular digestion? Is that digestive tract inside our body?
Yes. No.
Is it made up of our cells inside the tubes here? No, so it's really the outside in ways, because we're like a donut, right? We need to just, I can't remember where I was going with that, but oh well. Okay, so moving on here. Okay, this is a very important, that epiglottis is very important. This is a little trap door. It allows you to get what you eat and drink going down the right tube. What tube is that? The esophagus. What's the other tube that we do not want to swallow liquids and food into? What is the breathing tube? The trachea. Okay, now, the esophagus, I said, was muscular, and it squishes stuff down it, right? The trachea is totally different. It has cartilage rings in it. It's more like a vacuum tube, right? You know how those vacuum tubes have the metal rings to keep it so it's open, or even plastic rings? That's different. That's your trachea. Where does your trachea lead to? The lungs, okay? I don't know if you guys realize this, if I shared this with any of you, but when I really, really hurt my back, I mean, my back was a mess before it really blew up. Did I tell any of you guys what happened? Believe it or not, this was when I, missed those other days, right at the beginning of the year. It was like the thing that really hurt me was I started coughing really bad because I had just left a little meeting. There was a little bit of cake there, and I was walking with my little cake in the napkin, and I tossed a little bit in my mouth. And I wasn't concentrating on eating. I don't know what happened. I didn't swallow right, and it went down the wrong tube. You know when that happens, and you have that huge coughing attack, and it just feels awful, right? Another time you feel this is, have you guys ever done this with Doritos? Very painful with Doritos. Lots of times if tortilla chips, Doritos, those triangle ones, you're chewing them, you're having fun. This is normally a party atmosphere when we're having Doritos and chips. You're talking, the epiglottis doesn't close correctly, you get it to go down your lungs, and it's not good, right? Hurts. And then that dumb coughing. But yeah, just that pressure in my muscles, and it was a bad one, where it was awful. That's what ended up hurting my back. Kind of lame. But anyway, so that's the epiglottis, and then peristalsis, that's what? Those are those muscle contractions squeezing the food through these tubes. Peristalsis. Again, if you're clueless on this stuff, go back to that National Geographic website. Okay, so I kind of went through all this stuff. We're making this soupy mess so that we can get the things broken down into little pieces and little chemicals so that we can absorb it. So the pancreas and the liver are also part of the digestive system. Again, they're the ones that are also making these different digestive juices. Okay. Okay, and then what we need to happen is those nutrients get absorbed in that the small intestines. We need to get those nutrients into blood, into the blood cells. And then again, we have the large intestines pulling out the water, and the undigested material eventually passes, right? Now, it says bacteria can help produce several vitamins and gases and other compounds also. The vitamins and much of the water that was mixed with the food is absorbed. So we can get some other elements and stuff out of the food when it's pulling the water out, because remember, water dissolves everything. So when we reabsorb that water, we still can get some good stuff that way also. And then the waste, the stuff that the body doesn't need, goes out the anus, and then we call it feces. Okay, so back to the cracker thing here, again, you have water is necessary also with this reaction, but the starch breaks down to, I basically was oversimplifying, but it's fine, with the glucose. I think maltose is 2 glucoses together. I'm not going to test you on that, but you do need to know that starch, with the help of the salivary amylase, when I said there's an ace on the end of something, what's that mean? It's a what? What is it? Like catalase? It's an enzyme. Okay? So I'm not worried about maltose if you want to just write glucose next to it too. Just making sure that you understand that we're getting the starch to break down into simpler sugars. And you can see that the carbohydrate digestion is done, finished in that small intestines. Okay, this is straight out of your book. I know it's difficult to read on there, but I wanted to show it to you so that maybe you would realize you better kind of look over this thing pretty good. But you have all the organs of the digestive system and what they do. Some more specifics, not that you need to have all that memorized by any means, but you need to be familiar with what all the organs do. Now back to the small intestines. So villi are those little finger-like projections. You can see them in the middle here with an electron microscope. Okay, so they're just all these finger-like projections. Over here, you can see a cross cut. It's an illustration, of course, you can tell that, of the small intestine tube. And you can see the inside of the tube is not flat. It's full of all those projections. Now, why? Why do you think it should have all these finger-like projections? Why not just a smooth cylinder or smooth tube? What do you think those villi, those finger-like projections, do? They're just increasing surface area. If it was just a flat tube, right, there wouldn't be that much surface for the absorption to take place. So now, instead of a flat side, if you have all these finger-like projections sticking out and the fluid is coming through, the soupy mixture is coming through, do you see how the soupy mixture is going to come in contact with the sides of the intestines this way? So this is a perfect example of form or form and function, right? Shape of the structures with what it does. So this allows for increased surface area because we want that soupy mixture with all those great chemicals that your body needs to come right next to that skin tissue there, and then it'll diffuse and get absorbed into the blood system, and then it can be taken into the bigger arteries and pumped throughout the body, and the cells that need these certain things have it available to them. Does that make some sense? Okay, so that's villi. And capillaries are the teeny vessels that that come to, that's like all let me, I can't talk, all the arteries branch out and get smaller and smaller until they're in these teeny capillaries, and then they go do their job there, whether it's collect oxygen like in the lungs, or if it's like this, collecting nutrients, and then it goes back to the veins eventually. That's the two colors there. Okay, let's see how you can do on your vocab practice right here. So just write it down on the side, and then I'll show you the answers.